video we're going to watch and we're going to listen what is the non-uniform bending method to find the Young's modulus of a rectangular beam. Here I have shown some setup, and then to do this we need some earlier ideas. Earlier I have taken a video. From that video you can watch to find the Young's modulus of a cantilever. If the cantilever length is L and then it is loaded in one end, weight W, then its Young's modulus will be equal to simply it has been written as the W weight added plus into the L cube, length cube, divided by 3 I geometrical inertia into Y, the depression created. Here how much because of the weight there will be a depression in the free end of the cantilever. So if you watch, there will be a free end of the cantilever, depression will be a Y. If you able to go through proper derivation by understanding the neutral surface will not make any change by applying the force, that length will not be changed, upper portion will be increases and lower portion will be decreases in the length. So with that idea we can able to get the values for Young's modulus in the cantilever case. So the same idea we are going to use it in case of non-uniform bending. Actually non-uniform bending, if a beam loaded at midpoint, if the weight is loaded at the midpoint of the beam, so here we are going to add the weight. Okay, because of that weight there will be a depression, then the depression produced on the beam does not make an arc of circle. So why it is so is in another case there is a uniform bending method. In that bending method the weight will be added in two sides of the beam, and then there will be a depression that will make an arc of a circle. But in this case then there will be no circle kind of thing, it will be non-uniform. This non-uniform arc, so this then only it is called as a non-uniform bending. Then this method is known as non-uniform bending method. If it is bending properly like an arc of circle, then that is uniform. Then if it is not bending as a not as a circle arc, then it will be a non-uniform bending. So this bending will be a kind of parabola type. So there will be depression of value Y. So you watch that. Now I am going to pick a point something like this is A and this is B. The length between A to B is L. So here the middle point is, will keep O. Okay, the midpoint of the beam is O. Consider a beam of that two knife edges K1 and K2 are kept at points A and B, that is equal distance and midpoint. So there will be no partial, only the left side will be same, and this in between length also will be same. So at exactly middle point we are going to load the weights. Okay, this is the setup of the non-uniform bending. So in that bending is like a inversed cantilever How? Because in this point there will be a weight acts upper side, and this B point there will be a force acting. If I am drawing free body diagram of this beam, then you can see if I am acting W on the lower side middle point, and I am going to keep some support here, then it will be equally distributed and the weight will be off the both side. So if it is make some arc, then I can note it down as this is a cantilever and it makes an angle W by 2 weight is added. So it is a 2 inverse cantilever is acted on this. So if you consider that inverse cantilever, then W, this midpoint is fixed point, from that it is length is L by 2. Okay, so now I can write that W, Young's modulus can be written as the weight is W by 2 and the length is L by 2, because this is inverse cantilever. So you have to think that like the L by 2 is length of the cantilever now. So I am going to substitute the values for Y, W, L cube. So W here is W by 2, half of the mass, and then 3 I. So it is a circular rectangular beam of breadth B and thickness D. So rectangular beam of breadth B and thickness D. So with that we can get the value for geometrical moment of inertia, that is I equal to B d cube by 12. So that I am going to write it in terms of B I am writing B d cube by 12, and then Y, that is a depression created. Okay, so now if you watch, the next step is simply I have to simplify the terms, algebraically simplify the terms. L cube divided by 2 power 3 will be 8, and denominator 12 will comes in a numerator. 3 B d cube small y, actually this is the capital Y, capital Y, so finally we will W L cube into 12 divided by 2 into 8 will be 16, 16 to 3 48 B d cube Y. So now this will be cancels with 12 into 4 times W L cube 4 B d cube Y. So moreover whenever we write W is nothing but mass into gravity L cube divided by 4 B d cube Y. So now the same thing is our result now. So the Young's modulus of the non-uniform bending, we will get the equation as mg L cube divided by 4 B d cube Y. This is for the new unit is meter square. This is for the non-uniform bending approach, we will get this result. So Young's modulus will be mass the acceleration of gravity and L cube length of that beam within the two knife edges, and the breadth and thickness and the depression created. So these things will help us to find the Young's modulus. If you are approaching to see uniform bending method, that is quite tedious, but it is simpler, we can able to do it. So this is for non-uniform bending. Bending method, the Young's modulus is y equal to mg L cube divided by 4 bd cube y. So the given values of L, because the given, if there is a beam of length L, then we can substitute all the values, then we can find the Young's modulus. Next case is uniform bending method. In this case, this is much simpler. I am going to make a beam will be placed on the two knife edges C and D, loaded in both the sides, both the edges. I am going to add from the midpoint, it is equal distance, and the A and B are equal distance from the midpoint F. So the midpoint is F, and the load added points are like A and B. So the our supportive knife edges are kept in C and D. So that length is L. So now consider this type of structure. So because of load acted on the both side equal distance, it will make a type of arc. That arc will be a part of the circle. Okay, that I will show very quickly. In between that, how much external force acted is, because this W, there will be opposite force acted on this knife edge above side, that will be W will be acted on in this side. So in leading side there will be a W. So because of that there will be elevation Y. So both the sides we are pushing down, so that midpoint it is getting elevation. So this here the Y is elevation. Earlier in non-uniform bending there is a depression or cantilever, that will be depression, but in this case it is a elevation. Okay, now I have to get the external, because I am applying giving the load W on this side. So I need to get the what is the value for external bending moment, which is to get the proper arc, how much it is making, because it is, if you see this, it has been like a couple. We are applying force in this two opposite direction, that weight is in this two opposite direction. If you see the free body diagram, so this will make type of an arc, so that moment will be like AC into the W. But if you see it properly, this external bending moment is the distance between the opposite force, that is A, and the force is W. So W into AC. So AC is nothing but WA. Okay. Now internal bending moment. Internal bending moment we have found for a beam, how it is bends, and we get the values as yi by r. So if you make some radius of curvature, the bending, then radius of curvature is I, y is Young's modulus. So already we seen y is Young's modulus, I is a geometric moment of inertia, and r is a radius. So now if this is an arc of length, consider this is an arc of our points, this is A and B. Now I am going to put it in the circle. Let me make a circle. The circle will going to fix in this point. So you see properly this arc will be fixed inside the circle. So here we will use some other color. So the point A, so this point A and point B, the length between these 2 points sorry, the points are like the points is consider only within this region, not a complete region, just to consider from C to D. So the points are C to D, and so the arc is from C to D is connected. So this is my this point, middle point E. Okay, now from E, so this top portion is my F. If you see these points C, D, E, F, or this E, F is now makes an arc. So now I need a cell line. So get the. So this is a diameter of the circle. Here I put point O and G. There is a quad law of the circle is there. There is a one law which is a mathematical law. This is quad law of circle. What that quad law is telling is, if two lines are cutting a circle, okay, if this two lines CD and FG are cutting the circle edges, then that length, because here this CD length is L, total length is CD is L. Now half of the length is CF, CE is L by 2, ED is L by 2, and the radius of the circle is R, and this length is Y. EF length is Y. So get the EF value equal to Y, and the CD length is L, but our half of the length is CE length is L by 2. What this chord law of circle is telling us is the CE into ED equal to EG into EF. That means this two distance multiply will be equal to this two distance. Okay, so that's what it is telling. If you make some proper trigonometric idea, then you will get this formula CE into ED. So CE and ED are equal, that is L by 2 into L by 2 equal to EG is nothing but R 2R minus Y. So EG is 2R minus Y. How it is? Because the diameter is 2R, and you have to minus this Y distance, because that is what our EG into EF is my Y. So this equation is, so let's bring it here, L square by 4, because L by 2 into L by 2 is L square by 4, and 2R minus Y into Y. Why it is, so just do some algebraic thing, 2RY minus Y square. Now consider, if this arc is very small, this Y will be very less. So then Y square will be next, then neglect Y square. If it is neglecting neglect the Y square, then this will be L square by 4 equal to 2RY, then R, which is equal to L square by 8Y. Okay, why I need to get the value for R in terms of the known values? L square and Y are known values, but R is unknown value, because some radius of curvature that we cannot measure in here. So we have to get the idea. So we already got that idea. Why it is so is, now we have to equate. If the force are equal, then internal bending moment is equal to, so it is internal bending moment equal to external bending moment. That is WA equal to YI by R. So far it is okay, fine. And I found what is the value for R. So let me write down the equation. Substitute, if you substitute the value of R here, then that is L square by 8y. WA equal to YI into L square into 8y. So whatever it is in denominator will come into numerator. So simple now. So I need to find the value of y, that is Young's modulus. So keep Young's modulus on one side and bring other terms in the other side. Then we will get it as WA L square. So L square denominator will comes in numerator, and I 8i y. So we know what is I. I is nothing but, if it is a, so already we have discussed so many times that the value of I in the rectangular beam, I and W is nothing but W equal to mg, mass into acceleration of gravity. So the Young's modulus of the, so here Young's modulus of uniform bending method will be mg L square, and I have missed mg L square into A divided by 8 BD cube by 12. So this is Young's modulus of rectangular beam. Rectangular beam VD cube by O and into SY. So if it is simplify now, then I will arrive at 3 mg L square A divided by 2 BD cube small y Newton meter square. So this way we have arrived for the Young's modulus in two different methods. One is uniform bending and another is, this is non-uniform bending Young's modulus value, Young's modulus formula. So if you vary the approach, if you apply the loads on different points, then we will get the different formula.